What if everything protecting life on Earth is completely invisible? What if the Earth had no atmosphere? Well, what if the very air we breathe simply vanished? It is a strange thought. Above us, there is a vast and invisible ocean of air. We live at the very bottom of this ocean. It is a blanket of gases. This blanket is our atmosphere. It is not just one single thing. It is made of many layers, stacked one on top of the other. Each layer has a very specific and vital role. They work in perfect harmony. They are the unseen protectors of all life on this remarkable planet. This great shield surrounds our world completely. It gives us the oxygen we need for every breath. It regulates our planet's temperature, preventing the extreme heat of day and the bitter cold of night that exist on worlds without air. The atmosphere also acts as a powerful barrier. It defends us from harmful radiation streaming from the sun. It protects us from the constant bombardment of rocks and debris from space. We often forget it is even there. We move through it, live within it, and depend on it for our very survival, yet it remains almost entirely unnoticed. To understand this shield, we must look at its parts. There are 5 main layers. Each one is different from the last. As you travel upwards from the ground, the air changes, the pressure changes, the temperature changes. The very purpose of the air changes. From the dense, weather-filled layer we call home to the thin, final wisps that touch the void of space, each zone is a world unto itself. Understanding these layers helps us appreciate the delicate and complex system that makes our world a living one. It is a journey upwards, into the sky. Imagine peeling back these layers one by one. It is like unwrapping a precious gift. Each layer reveals a new secret, a new function that is essential for life below. The first layer is the troposphere. This is our home. It is the layer that rests directly on the surface of the Earth. If the atmosphere is an ocean, the troposphere is the water we swim in every day. It contains nearly all of the water vapor and the vast majority of the air molecules in the entire atmosphere. It is the densest of all the layers. Every breath you take draws air from this vital zone. All the life we know, from the smallest insect to the largest whale, exists within or depends upon the troposphere. It is the very cradle of our world. This is also the layer of weather. The sun heats the ground, and the ground warms the air above it. This warm air rises, cools, and sinks again. This constant churning, this circulation, creates everything we call weather. It creates the gentle breezes and the powerful storms. It forms the fluffy white clouds on a summer day and the dark, heavy clouds that bring rain. The troposphere is a place of constant change and activity. It is where winds blow across continents and where rain falls to nourish the land. The troposphere is a relatively thin band. If the Earth were the size of an apple, this layer would be thinner than its skin. Yet within this thin space, all the drama of our planet's climate unfolds. Commercial airplanes fly within the troposphere, often near its upper boundary to find smoother air above the most active weather systems. Birds soar on its currents. The sounds of our world travel through its dense air. It is the layer we are most familiar with, the one that touches our skin and fills our lungs with every moment. Without the troposphere, there would be no breath to take. There would be no clouds to provide shade or rain. There would be no wind to carry seeds across the land. The world would fall silent. The complex cycles of water and air that sustain ecosystems would cease to exist. Life as we know it is fundamentally tied to this first, most active, and most immediate layer of our atmosphere. It is the very breath of our planet, constantly moving, shifting, and giving life to the world below. Above the churning weather of the troposphere lies a calmer realm. This is the stratosphere. Here, the air is much thinner and more stable. There are no storms or clouds to speak of. The winds, when they exist, are steady and flow in vast sheets. For this reason, long-distance jets sometimes climb into the lower stratosphere to take advantage of the smooth ride, flying above the turbulence of the world below. It is a layer of profound peace compared to the constant motion of the troposphere. A quiet, settled sea of air. The most important feature of the stratosphere is not something you can see. It is a special type of oxygen molecule called ozone. These molecules form a thin layer known as the ozone layer. This layer performs a task that is absolutely critical for life on Earth. It acts as a planetary sunscreen, It absorbs the majority of the sun's harmful ultraviolet, or UV, radiation. This radiation is powerful enough to damage the very building blocks of life, the DNA within living cells. The ozone layer is our silent guardian against this invisible threat. The temperature in the stratosphere behaves in a curious way. Unlike the troposphere, where it gets colder as you go up, the stratosphere gets warmer with increasing altitude. This is because the ozone layer is absorbing that powerful energy from the sun. This absorption process heats the air around it. This warming is what keeps the stratosphere stable and stratified, with warmer air sitting on top of cooler air. It prevents the mixing and churning that creates weather in the layer below, creating a distinct and separate atmospheric zone. Without the stratosphere and its ozone layer, the sun's rays would become a deadly force. The surface of the Earth would be bathed in intense UV radiation. This would make it incredibly difficult for most plants to grow. It would cause severe harm to animals. It would cause severe harm to humans. The very surface of the oceans would be sterilized. The stratosphere, therefore, is not just a layer of air. It is a fundamental shield. It allows life to thrive in the gentle sunlight that filters through, protected from the harsher glare of our star. As we continue our journey upward, we leave the warmth of the stratosphere behind and enter the mesosphere. The name means middle sphere, and it is here that the temperature begins to plunge once again. In fact, the very top of the mesosphere is the coldest place in the entire Earth system. Temperatures can drop to unimaginably frigid levels, far colder than any natural temperature recorded on the surface. The air here is incredibly thin, with molecules spread far apart from one another. It is a vast, cold, nearly empty space. Despite its emptiness, the mesosphere provides another form of crucial protection for the world below. This is the realm where most meteors meet their end. Every day, millions of small rocks, pieces of space dust, enter our atmosphere at incredible speeds. When one of these objects hits the thin air of the mesosphere, friction is created. This friction is so intense that it heats the meteoroid until it glows brightly and vaporizes. What we see from the ground is a beautiful, fleeting streak of light. We call it a shooting star. These shooting stars are a visible reminder of the constant work our atmosphere does. The mesosphere acts as a fiery shield, burning up the vast majority of this incoming debris before it can ever reach the ground. While larger objects can sometimes punch through, this layer protects the surface from a constant rain of smaller space rocks. Without the mesosphere, our planet's surface would be much more heavily cratered, and the danger from falling objects would be a far more common occurrence. It is a silent, high-altitude defense system. So, while the mesosphere is a place of extreme cold and thin air, it is also a place of intense, fiery events. It is a protective barrier that turns potential threats into harmless flashes of light in the night sky. It is a testament to how even the thinnest of air, when encountered at tremendous speed, can create a powerful shield. This middle layer, so far above our heads, is constantly at work, sweeping the space around our planet clean of small intruders and making the world below a safer place to be. Beyond the frigid mesosphere, we find a layer where the temperature does something extraordinary. We enter the thermosphere. As its name suggests, this is a region of high heat. The temperatures here can soar to incredible heights, far hotter than a furnace on Earth. This heat, however, is not what you might imagine. The air is so astonishingly thin, with individual molecules separated by vast distances, that it would not feel hot to us. There are simply not enough particles to transfer that heat energy to an object like a person or a spaceship. The source of this intense heat is the sun. The thermosphere is the first layer to receive the sun's most energetic radiation, extreme ultraviolet light, X-rays. The few gas molecules that exist here absorb this powerful energy directly, causing them to become very excited and move at very high speeds. This high speed is what we measure as high temperature. The International Space Station, many other satellites, orbit the Earth within this vast, hot, and nearly empty layer, gliding through the thin gas. The thermosphere is also home to one of nature's most spectacular displays, the aurora. When the sun releases a burst of charged particles, the solar wind, some of these particles are funneled by Earth's magnetic field toward the poles. As they stream into the thermosphere, they collide with the atoms of oxygen and nitrogen. These collisions excite the atoms, causing them to release their extra energy in the form of light. The result is the beautiful, dancing curtains of color that grace the polar skies. This layer is a dynamic interface between Earth and space. It swells and shrinks in response to the sun's activity. When the sun is active, the thermosphere heats up and expands, creating more drag on satellites. When the sun is quiet, it cools and contracts. It is a place of invisible energy and visible light, absorbing its power and turning it into both incredible heat and breathtaking beauty. Finally, we reach the outermost fringe of our atmosphere. This is the exosphere. The name means outer sphere, and it is the final frontier between our world and the vacuum of space. There is no clear boundary where the exosphere ends. It simply fades away. The air here is so incredibly thin that it is no longer like a gas at all. It is more like a collection of individual particles on long, arcing journeys. Some of these particles are still bound by Earth's gravity, but others are moving fast enough to escape and drift away into the solar system forever. This is the edge of our world's breadth. The molecules here, mostly hydrogen, helium, are so far apart that they can travel for hundreds of kilometers without bumping into one another. It is a place of immense silence and solitude. Satellites that orbit in this region experience very little drag as they move through the near-perfect vacuum. The exosphere represents the last tenuous hold that Earth's gravity has on its atmosphere. It is the final, gentle whisper of air before the utter emptiness of interplanetary space begins. The exosphere serves as a final, subtle reminder of the fragility of our atmospheric blanket. It shows us how our planet's influence gradually diminishes, blending slowly and seamlessly into the vastness of the cosmos. It is not a hard wall or a sudden stop, but a slow, graceful transition. Looking back from this vantage point, the Earth would appear as a brilliant blue and white marble, its thin, life-giving sheath of air barely visible against the blackness. This layer is the quiet evidence of our planet's presence in the universe. All these layers, from the dense troposphere to the fading exosphere, work together as one cohesive system. They give us air, water, warmth. They shield us from radiation and burn up meteors. They paint the sky with clouds and auroras. We live our lives under this complex, invisible, and life-sustaining shield, often without a second thought. These invisible layers protect everything you know, without you ever noticing them. But what if this intricate system, this gift of air, was not here? What would our world truly be without the quiet, constant work of the atmosphere? So the real question is, what would happen if they disappeared?